somewhere in space, right now, there's a place where the laws of physics as we understand them simply stop making sense. It's not a planet, not a star, not even really a thing in the way we normally think about objects. It's a black hole. And if you fell into one, what would actually happen to you is stranger and somehow more terrifying than almost anything science fiction has ever imagined. Let's start with what a black hole actually is. It's a region of space where gravity is so extreme that nothing, not light, not matter, not even information itself, can escape once it crosses a certain boundary. That boundary is called the event horizon. It's not a physical surface you'd bump into. It's simply the point of no return. Cross it, and there is mathematically no path, no amount of speed or thrust that gets you back out. Here's where things get strange almost immediately. As you approach the event horizon feet first, gravity pulls harder on your feet than on your head because your feet are slightly closer to the black hole. For a small black hole, this difference would be so extreme that your body would be stretched into a long, thin strand, a process astrophysicists actually and seriously call spaghettification. But here's a twist most people don't expect. For a supermassive black hole, like the ones found at the centers of galaxies, the math changes completely. Because these black holes are so enormous, their event horizons are much farther from the extreme gravity at the center. That means you could actually cross the event horizon of a supermassive black hole without feeling any stretching at all. You might not even immediately realize you'd already passed the point of no return. That raises an unsettling question. If you can't feel yourself crossing it, would you even know? According to general relativity, the answer is genuinely unsettling. From your own perspective, falling in, there's no dramatic flash, no barrier, no alarm. You'd simply keep falling, and the universe outside would keep existing, seemingly forever, while your fate was already sealed. Meanwhile, something even stranger happens from the perspective of someone watching you from a safe distance. As you approach the event horizon, time itself appears to slow down for you from their point of view. You'd appear to move slower and slower, your image growing dimmer and more red-shifted until you seem to freeze at the edge forever. Even though, from your own perspective, you crossed it completely normally and kept falling in. We actually have direct proof that black holes are real, not just mathematical predictions. In 2019, an international team using a network of telescopes called the Event Horizon Telescope released the first ever photograph of a black hole's silhouette in a galaxy called M87, a glowing ring of superheated matter wrapped around a perfect, dark void. It matched the theoretical predictions almost exactly, decades after Einstein's equations first suggested black holes should exist at all. Telescopes have also caught black holes in the act of feeding. When a star wanders too close, the same tidal stretching that would happen to a falling human happens on a cosmic scale. The star gets torn apart into a glowing stream of gas in what astronomers call a tidal disruption event. We've now photographed several of these in progress, essentially capturing a star's actual death by spaghettification. Live, from millions of light years away. This isn't just theoretical speculation. It's a direct, tested consequence of Einstein's theory of general relativity, one of the most rigorously confirmed theories in all of physics. Gravity doesn't just pull on objects, it actually warps the fabric of space and time itself. Near a black hole, that warping becomes so intense that time and space essentially trade places in a way that's almost impossible to intuitively picture. There's one more twist inside the math that even most physicists find deeply strange. Most black holes in the universe are spinning, and a spinning black hole's singularity isn't a single crushing point. Equations describe it instead as a thin, glowing ring. Some theoretical work suggests that falling through the exact center of that ring, rather than into it, could avoid the infinite crushing entirely, potentially connecting to another region of space-time altogether. Almost every physicist agrees this is likely destroyed by other effects in reality. But the fact that the pure math even allows for it shows just how far these objects push our equations past their comfort zone. Once you're inside the event horizon, heading toward the center, physicists describe something even more bizarre: the singularity. This is a point where, according to our current equations, gravity becomes infinite, and the density of matter becomes infinite too. Space and time as concepts appear to break down entirely. Here's the uncomfortable truth scientists will readily admit. Nobody actually knows what happens at the singularity, because our best physical theories, general relativity and quantum mechanics, completely contradict each other at that scale. This is actually one of the biggest open problems in modern physics. Scientists call it the information paradox. If a black hole eventually evaporates over unimaginable timescales through a process called Hawking radiation, first proposed by physicist Stephen Hawking, then what happens to everything that fell in, including, theoretically, you? Does the information that made up your body simply vanish from the universe forever? Nearly every law of physics we know says information cannot be destroyed, and yet a black hole seems to do exactly that. For decades, this contradiction genuinely divided the physics community. Some argued the information gets encoded somehow on the event horizon itself, like a hologram of everything that ever fell in. Others proposed even stranger ideas, including the existence of a firewall of high-energy particles right at the horizon that would incinerate anything crossing it instantly, directly contradicting the calm, gradual fall that general relativity predicts. Here's the twist that connects all of this back to something happening in real research labs right now. Scientists have started building small-scale laboratory analogs of black holes using sound waves in specially cooled fluids instead of actual gravity. These sonic black holes can't swallow matter, but they do trap sound waves in eerily similar ways. And in 2019, researchers detected something that behaved almost exactly like the radiation Hawking predicted, coming from one of these lab-created analogs. It was strong evidence from an actual laboratory that Hawking's decades-old and purely theoretical prediction about real black holes might genuinely be correct. So science still doesn't have a final, agreed-upon answer to what would truly happen to you, or to the information that made you if you fell into a black hole. What we do know is this: it would look calm and gradual from your side, catastrophic and frozen from an outside observer's side. And at the very center, our current laws of physics simply give up entirely. And that's what makes black holes different from almost every other mystery we've covered. It's not something we're waiting to discover with a better telescope. It's a place where the universe's own rulebook runs out of pages, right at the edge of something we've already proven is real. In the next video, we're leaving black holes behind for something quieter, but just as strange. The story of humanity's most isolated object, a small metal spacecraft currently drifting further from home than anything else we've ever built, still sending back a signal from outside our solar system. Subscribe, because that one is a genuinely emotional kind of lonely.